We got a tank that has a height of 10 feet. We can see like 0, 2, 5, 10 feet. The area of the horizontal cross section is given in the chart, and we want to use the left Riemann sum with 3 subintervals to approximate the volume of the tank. That should be pretty straightforward. And then we're going to indicate units of measure. So how do we go about that? We're using the left Riemann sum. So what do we do? Yep, start with the first leftmost endpoint, 50.3 times the length of that interval, which is 2. And then add the next one, which is a length of 3 times the height of 14.4, plus the next one, which was 5 times 6.5. And we don't have to worry about the 2.9. If we're doing a right Riemann sum, we start on the right. Yep. And what did that come out to be? What was that? 176.3. And what are your units on this? Oh, well, yeah. So we are integrating our area, right? So yeah. Here, what are we? Were they feet? They're feet, yeah, cubic feet. Everybody good with that? Any issues there? All good. People in the Zoom, you're all good with that?
Yeah.
Great. Is this approximation an overestimate or an underestimate? That should be straightforward because what did they tell you about this function? That A is continuous and decreasing. So if the function is decreasing and it's a left Riemann sum, what are those rectangles going to do? They're going to overestimate because A of H is decreasing. Easy enough? Wonderful. All right. Let's see here. The first one was worth 2 points, 1 for the setup and 1 for the answer. And then they gave you 1 point if you had the correct units anywhere in A, C, or D. No, never mind. You had to have the correct units in A, C, and D. So we won't give that point yet. And then part B was just worth 1 point. Okay, cool. So then for part C, the area in square feet of the horizontal cross section is modeled by this function. Find the volume of the tank. So how do we do that? We just integrate it from 0 to 10. Integrate 0 to 10 f of h dh. And that came out to be 101.325. And what were your units on that? Cubic feet. Yep. That was worth 2 points, 1 for the integral setup, 1 for the answer, and you had to have those units there to get that final point once you also get the units in part D. Everybody good? No issues there? People at home, you're good?
Yep.
All right. Then we got water pumped into the tank. When the height of the water is 5 feet, the height is increasing at 0.26 feet per minute. We want to find the rate at which the volume is changing with respect to time. So what is the equation that represents the volume? An integral from 0 to h of f of x dx, right? That's the function that represents the volume of this at any time, right? So if we are looking for the rate of change, the rate at which the volume of the water is changing, the rate of change of the volume, what do we have to do with that? We have to take the derivative of it with respect to t. So this will become dv dt. And what's the derivative of the integral from 0 to h of f of x? Should be f of, well, f of h dh dt, right? Isn't that how that works, right? This is just a constant to a function, sorry, constant to a variable of some function. So its derivative is just that function evaluated at that variable. That's the first part of the fundamental theorem of calculus. So then all we got to do is plug in all the values. So let's see, we're talking about when the height is 5. So we've got dv dt equals f of 5. And then the rate of change of the height at 5 is 0.26. So all we have to do is find f of 5, which you've got the equation for that, and multiply it by 0.26. And that comes out to be 1.694. And what are the units on that? It's a change with respect to time of the volume, which is feet cubed per minute. And so that was worth 2 points, 2 points for the value here, and then 1 point then at the end for having all of the units in A, C, and D. Okay? Any questions or issues on that one? Well, it says, I don't know, it's a little confusing. It says dv dt, 2 points. So I assume that's, I don't know, they might have split it up and gave you like 1 point if you had this, and then 1 point for the answer, if you had the f of h dt, but usually they would break that down. And so what it, I mean, it just says dv dt. So my assumption is it's the answer. Anybody have any questions on that one? Feel okay about that one? Yeah. We're gonna have a quiz on Friday that will be miscellaneous free response questions. Very exciting. Just pick some random. What? It could be just anything. It could be, I mean, you know, it won't be one to fit into the other categories. So like it won't be an area volume one, it won't be a differential equation one, it won't be a rate one specifically. It'll be something like, you know, like this one, or like the one we just did. Yeah, won't that be fun? Everybody will enjoy that. All right. How'd this second one go? Would it go okay or no? All right. Let's see. Find the slope of the line tangent to f at x equals pi. Well, f of x is cosine 2x plus e to the sine x. So if we're looking for the slope of the tangent line at pi, all we have to do is take the derivative of that and evaluate it at pi. So what's f prime of x? Let's see. The derivative of cosine of 2x ought to be negative 2 sine 2x, and the derivative of e to the sine x ought to be e to the sine x times cosine. So at pi, what's the sine of 2 pi? 0. And let's see, the cosine of pi is negative 1 times e to the 0. It should be negative 1 times 1, so that should be 0 minus 1, or negative 1. Good? Everybody good with that? Let's see here. In the process of pulling this one up, so I don't know how many points. My guess is that was worth 2 points. Give me a half second here and I'll find that out. Looks like that was worth. There, it was right. 2 points. Look at that. 2 points. Both though, just for getting the answer of negative 1. No points if you took the derivative correctly. You had to get f prime of pi correct to get 2 points. All right, part B. Let k be the function defined by k of x is h of f of x. So if k is h of f of x and we want to find k prime of pi, we need to take the derivative of k using which rule? Chain rule, because this is a composition of two functions. So the derivative of a composition, h of f, should be what? K prime ought to be h prime of f times f prime. Right? That's how that chain rule works, right? The derivative of the outer function, so h prime, evaluated at the inner function, f, so h prime of f, times the derivative of the inner function, f prime. So we are looking for, let's see here, h prime of f of pi times f prime of pi. So that ought to be h prime of something times f prime of pi, which is what? We just found that, right? That was -1. So then we need to figure out what is f of pi. So we go back to our original. What's f of pi? What's the cosine of 2 pi? 1, right? And then e to the sine of pi. Sine of pi is, so e to the 0 should be another 1. So f of pi is 2. Everybody good with that? So now we're looking at h prime of 2 times -1. So we got to go back here again and figure out what is h prime of 2. Well, h prime of 2 is the slope of h when x is 2. Well, that's just this linear piece right here. What is the slope of that linear piece? It's down 1 and to the right 3, -1/3. So h prime of 2 is -1/3 times -1, or just +1/3. And that was worth 2 points. 1 point for this expression that we wrote for k prime of x, and 1 point for the final answer. Any questions there on part B? People at home in the Zoom, any questions on part B? People here are good? Y'all are good?
I think we're good.
You think you're good? Okay, good. Part C, oh, another new function, m. M is g of -2x times h of x. So let's write that down. G of -2x times h of x. Sorry. So we're looking for m prime of 2, which means we need to find out what m prime of x is. This time, what rule are we going to use? Product rule. We'll start with g of -2x times the derivative of h. And then we will take the derivative of g of -2x and multiply it by just h. So there's our h. What's the derivative of g of -2x? That's still a composition of functions. That's g of u, with u equal to -2x. So that ought to be what? -2 times g prime of -2x. Take the derivative of the g, so g prime, evaluated at the -2x, and then multiply that by the derivative of -2x. Everybody good there? Chain rule on the derivative there within the product rule? All right, and I assume we're looking to evaluate that at pi also? No, at 2, m prime of 2. So m prime of 2 ought to be g of -4, h prime of 2, plus h of 2 times -2 times g prime of -4. And now we'll have to go back and look at the graph and look at the chart to figure out what all those things are. So g of -4, looks like that's 5. H prime of 2, we just found that earlier, right? H prime of 2 was -1/3. And then h of 2, we didn't have that. What's h of 2? Well, we know the slope there, so h of 2 must be -2/3. And then we've got -2 times g prime of -4. Well, g prime of -4 is -1. So that's -2 times -1, which is 2. So we've got -5/3 minus 4/3, which is -3. That was worth 3 points. They gave you 2 points for the expression for m prime and 1 point for the final answer. Good or no? Feeling okay about this one? Yeah? All right. One part left, right? Part D. Is there a number C on the closed interval -5 to -3 such that G prime of C is equal to -4. So what are the two different ways we could look to see if that's true? Two different theorems we could potentially use. Intermediate value theorem and mean value theorem. If we think about the intermediate value theorem, then we need to look at the values of G prime. And we need to know that G prime is continuous. So it says that G is differentiable. So if G is differentiable, that means that the derivative exists at every single value on this chart, right? Yeah, or well, just for every single value. Does that guarantee you that G is a continuous function? Yeah, it should be. So let's see, what are we looking at? -5 to -3. So from -5 to -3, it went from -3 to 4 in G prime. Does that mean that it must have gone through -4? Nope, -4 is not in between there. So then, what's the other option? The other option is to look at the values of G. So we'll do 2 minus 10 over -3 minus -5. And what does that give us? That gives us -8 over 2, which is -4. And so we would state that G is continuous and differentiable. We know it's continuous because it says it's differentiable. And we know it's differentiable because it says it's differentiable. So G is continuous and differentiable. So by the MVT, yes. If the average rate of change is -4, so the instantaneous rate of change on that interval must be -4 at some point as well. And that was worth 2 points. 1 for showing this average rate of change is -4, and 1 with yes, because of the mean value theorem, with some explanation that G was continuous and differentiable. If you wrote G as continuous differentiable, so by the MVT, yes. And then if you have this work there, you're good. That is, I mean, yeah, I mean, the only thing they wrote, you know, they wrote the same thing, except they defined the interval. They said it's defined in differentiable on -5 to -3, which is probably best. I mean, but it says up here it's differentiable function, so we know that it's, I mean, if you state that it's on the entire interval, then it must be on that small interval too. The only other thing that they wrote was, I mean, they wrote it all out. Therefore, by the mean value theorem, there is at least one value C on -5 to -3 such that G prime of C equals -4. I mean, they wrote out the whole thing, but I don't think you need to write out the whole thing. Yeah, I mean, I don't think it's necessary to write it all the way out. To answer your question, DM, it just depends. I mean, I would say more often than not, the answer is yes, but that doesn't mean that it is. So I wouldn't just say yes. You got to check the two theorems and see if it's true. Sometimes the function will be continuous or differentiable, so you can't use the theorem and it doesn't work, or what have you. All right. Everybody good there with that one? Ready to do the next one? This one's fairly similar to the one we just did. I'll pull up our scoring guides here. So that I don't have to wait. All right, here we go. K is f of g of x. Write an equation that's line tangent to k at x equals 3. So that means we're looking for k prime of 3. And we're looking for the point on k where x is 3, right? So the point on k where x is 3 ought to be f of g of 3. And what is f of g of 3? G of 3 is 6. So we are looking for f of 6. F of 6 is 4. What? I don't yet, because right now we're just looking for k of 3. We're trying to write the equation of the tangent line, so we need both k prime of 3 and k of 3. We need the value, we need the point, and we need the slope. So I was finding the point, k of 3 first. Then k prime of 3, we'll need k prime of x for that. And what is k prime of x? That's a composition, right? So it should be f prime of g times g prime. So k prime of 3 ought to be f prime of g of 3. And what was g of 3? G of 3 was 6. So we got f prime of 6 times g prime of 3. G prime of 3 is 2. And f prime of 6 is 5. So this is 10. Everybody good with that? So we got y minus 4 equals 10 times x minus 3 is our tangent line. That was worth 3 points. 2 points for the slope and 1 point for the equation. Everybody good there? Okay. Now we've got h of x is g over f. Find h prime of 1. So if h is g over f, what is h prime? We got to use the quotient rule. So that'd be f times derivative of g minus g times derivative of f over f squared. And we're going to evaluate all of those at 1. So what's f of 1? Should be negative 6. G prime of 1 ought to be 8. G of 1 ought to be 2. And f prime of 1 was 3, right? And then all over f, which was what? Negative 6. So we got negative 48 minus 6 over 36. So negative 54 over 36. Yeah, those both divide by 18. Right? Yeah, I can do arithmetic. It should be negative 3/2. Good? That was worth 3 points. 2 points for your expression for h prime and 1 point for the answer. Any questions there on that one? Runs good. All right, and lastly, evaluating the integral from 1 to 3 of f double prime of 2x. Was it 1 to 3, right, of f double prime of 2x? Yeah. How are we going to do that? Yeah, we're gonna have to do a u substitution, right? So u is gonna be 2x du is gonna be 2 dx, which means we'll put in the 1/2 on the outside and the 2 on the inside. Those will cancel each other out, but not really, because the 2 is gonna disappear with the dx, and we'll end up with 1/2 of the integral from where to where? What's the lower limit of our integral? 2, and the upper limit's going to be 6, right? We're going to plug in 1 as x, and we're going to plug in 3 as x. Then we're going to get, now it's going to be f double prime of u du. And what's the integral of f double prime? It's just f prime, right? So we have 1/2 f prime of u from 2 to 6. So this is 1/2 of f prime of 6 minus f prime of 2, which ought to be a half of, let's see, f prime of 6 is 5, and then 2 is negative 2, so 5 minus negative 2, which looks like that is 7 over 2. Good or no? Looks like that was worth 3 points. 2 points for having the correct antiderivative here, 1 point for the correct answer. Yeah. Sure. Good. Yep. Anybody else? Any other questions on that one? You mean if you just wrote that's 1/2 f prime of 2x, or sorry, 1/2 f double prime of 2. Yeah, because you left it as 2x, then yeah, leave them as 1 and 3. Yep, that is totally fine. We feeling good? Yeah? What's the multiple choice section for tomorrow? Yeah. Sure, but that's not the multiple choice section for tomorrow. It is, sure, differential equations, is that what I said? Yeah. All right, so make sure that that's done for tomorrow, differential equations. And then we'll go over those. We have lots of time though, huh? That's good news. So let's do some more of these, huh? Let's see here. I think that'd be a good one. Let's do this one. Requires some implicit differentiation, some second derivatives of an implicit derivative. Some fun stuff. I think it's a good one, yeah? Let's do this one. It's just the next one in that packet. So we'll go with 15 minutes here to work through it, and then we'll talk about it. Ready, go. Part A, write the equation of the tangent line at -1, 1. So we've already got the point. We just need to find the slope. So we will evaluate this derivative at x equals -1, y equals 1. Which should be what? 1 over 3 times 1 squared, so 3 minus -1. That should just be 1/4. So that should be y minus 1 equals 1/4 times x plus 1. Good? Part A, good? Easy enough? All right, part B. We want to figure out when the tangent to the curve, find all coordinate from the coordinates of all points on the curve at which the tangent to the curve at that point is vertical. So we're looking for vertical tangent lines. What does a vertical tangent line tell you? Right, dy dx needs to be undefined, which means that the denominator needs to equal 0, which means that 3y squared minus x needs to equal 0. Yeah? So how are we going to figure out when that's true? Yeah, so x equals 3y squared, and then what are we going to do with that? How's that going to help us? We're looking for the coordinates of the points on the curve. So we want to know when on our curve does x equal 3y squared. How do we determine on the curve that we're given when x is 3y squared? Let's do that. Let's plug in x equals 3y squared in for x in the original equation. What does that give us? It gives us y cubed minus 3y cubed equals 2. So it gives us -2y cubed equals 2, or y cubed is -1, or y is -1. Everybody good with that? So y equals -1 is the y coordinate of where our tangent line is vertical. We need the coordinates of all points, so we need to plug in y equals -1 back into that. -1 cubed is -1. Minus xy should become plus x if we plug in -1 for y, equals 2. And so that gives us an x value of 3. So 3, -1. And that was worth 3 points. 1 point for setting the denominator equal to 0. 1 point for getting this original equation into one variable. 1 point for the coordinates 3, -1. And part A was 2 points, 1 for the slope and 1 for the equation. Everybody good with A and B? All right. Part C, evaluate the second derivative at the point where x is -1, y is 1. So to find the second derivative, we'll have to take the derivative of that first derivative. With respect to x, we'll have to use the quotient rule, exactly. So it will become 3y squared minus x. And then in our numerator, we had y, so that'll just become dy dx. And then minus, we have a y, and then a derivative of the 3y squared minus x, which will be 6y dy dx minus 1. And then that's all over that denominator, which was 3y squared minus x squared. Everybody good with the setup there? And what are we evaluating this at the point? Is it 1, -1 or -1, 1? So when x is -1 and y is 1. And we know that when x is -1 and y is 1, dy dx is 1/4. So we know that x is -1, y is 1, and all dy dx's can be replaced with 1/4. So we've got 3 times y squared, that should be 3, minus a -1 ought to be 4. So we got 4 times a 4, minus our y value, which was 1, so that's just 1. Then we got 6 times a 4, so that ought to be 3/2 minus 1. And then all over 3y squared is still 3, minus the -1 is still 4, squared is now 16. So we've got 1 minus 3/2 minus 1, which is half, all over 16. So we got a half divided by 16, which ought to be 1/32. And that was worth 4 points. 2 points for the correct second derivative. 1 point if you plugged in 1/4 for dy dx everywhere, and then 1 point for the final answer. Any questions on that? All right. Okay, real quickly before I have you guys do one more, I got to make sure I tell all the Zoom people. Tomorrow, if you are in 11th grade, some of you at home are in 11th grade, correct?
Yeah.
Great. If you are in 11th grade, tomorrow, we have to take the district math something stupid test. So we got to do that tomorrow. We're going to do that at the very beginning of the class period. I will give you the link. You will need scratch paper and a pencil. You will need your laptop. If you're at home, I guess you don't need headphones. It says you need headphones, but that's probably only for the people that are here. It says you're allowed to use a calculator. So if you want to have a calculator, that's fine. I don't honestly think it'll probably be that helpful. I don't know. I don't know anything about this test other than that I have to give it to you. And it's better than taking like 4 days of state testing. So this is the other option, is a day of this testing. No, I didn't hear back about people taking the AP test tomorrow about what they should do. Let me try again about that. Give me 1 second here. I don't know. Good question. Hopefully I get an answer in the next 20 minutes about what to do if you're absent. So yeah, sent rather than an email this time, I just texted the principal. So make sure that you're all ready for that. You're gonna have to do the same thing on Thursday, but in your second period class with like an English test. And then some other test in like a week or two after that. I don't even know. So just sorry, we have to do that. Those of you that are seniors, just show up to the Zoom if you're not here in person. And then I will have some stuff that I tell you guys to work on during that. And then we'll have some time after they're done to go over the multiple choice, hopefully. That's the hope, at least. Cool. Anybody have any questions on that? Okay. I just got a response from the principal for those of you that are going to be taking an AP test tomorrow. Or I don't know, Justin, if you're are you absent for an AP test, Justin, or are you just absent? Either way, it doesn't matter. I'm going to send you the link, and he says just take it on your own time. So whenever you get a chance to do it, just do it. I guess. I don't know. Fun times. Lucky you. All right, let's do one more. Grass clip, yeah, decomposing grass clippings. That sounds like fun, huh? Yeah, it's a calculator problem. Let's do this decomposing grass clippings question. I don't think we really don't have time to go through this one, so this will be the first one that we go over the next time we have a chance to go over any of them. But I'll give you 15 minutes right now to work on it. Ready? Go.